Okay, in this video, we're going to start section 1.2, and again, these are some concepts many of you have probably seen before. Graphs of equations in two variables, in particular how to plot things in the Cartesian plane or the XY plane. This first part might be a little bit elementary, so if you want to fast forward this to some more interesting parts, be my guest. Just want to make sure that we're all on the same page, knowing how the XY plane works. We have the x-axis, the y-axis, and every point on the plane corresponds to an ordered pair. And so, for example, if we want to plot the point 3, 5, this means x is 3, y is negative 5. So here's 3. Here's negative 5, and so there's our point. Okay, that would be 3, 5. And then 0, 4, in this case x is 0, y is 4. So that point would be up here. Okay, so there's nothing to that, hopefully. The more interesting is the graph of an equation. Okay, an equation in two variables, if they're x and y, gives a relationship between the x-coordinate and the y-coordinate. And then the graph of the equation just corresponds to all points x, y that satisfy that equation. Okay, so in this first example 2, the graph of y equals x, it's just all the points where the x-coordinate equals the y-coordinate. Okay, and you're probably familiar with that. Now we could, if we wanted to, we could plot a few points. We could say here's x and y, but it won't be too much here because if x is 0, y is 0. If x is 1, y is 1, and so on, right? And so we just get these points. This is a continuous. There's a whole bunch of numbers between consecutive integers, right? So we have to make this a nice continuous line like that. Okay. In example 3, we have the graph of x equals 3. You'll see that there is nothing. It doesn't say anything about the y-coordinate, but that's all right. That said, it just means the y can be anything as long as x is 3. And if we look at we just consider all the points whose x-coordinate is 3. And, it turns out that corresponds to a vertical line because we could have 3, 0, 3, 1, and so on. So whenever you have x equals a constant, that's always the vertical line. Okay. If we look at the graph of y equals x plus 1, that means the y-coordinate is always 1 more than the x-coordinate. So, again, if we can plot a few points here. Here's, say, 0. If x is 0, y is 0 plus 1 is 1. If x is 1, y is 2. If x is 2, y is 3. If x is negative 1, y is 0. Negative 2, y is 1. We can plot these points. We get 0, 1, 1, 2, 2, 3, okay, negative 1, 0, negative 2, 1. Okay. And I think most of us can recognize that this is going to be a line. Okay. We'll talk about lines in general very shortly, but we can see this is just a line. And as we get good at this, we're not going to plot any points to recognize. Once we recognize these first 3 types of equations, we're not going to really plot any points because that can just take too long. This next one, we have x squared equals y. But if we plot points here, say if x is equal to 0, we get 0. If x equals 1, we get 1. If x is -1, we also get 1. If x is 2, we get 4. -2, we get 4. And so if we plot these points, we get a parabola. It's actually the graph of y equals x squared. Okay. So these are something you should be able to, these graphs hopefully you've seen before. Okay. Now, first, the important thing you want to know about graphs is to know how to find the y-intercept and then find the x-intercept. That is, where does the graph intersect the x-axis and the y-axis. And it's very simple, or at least the general process is simple. To find the y-intercept, you set x equals 0 and solve for y. To find the x-intercept, you set y equals 0 and solve for x. So you just take the opposite, the other variable, set it equal to 0, and then solve for the variable you're looking for. So in this example, 4x plus 3y equals 1. If we want to find the y-intercept, we would set x equals 0. So we get 4 times 0 plus 3y equals 1. Okay, and of course this means that 3y is equal to 1. So y equals 1/3. Okay, and that's the y-intercept. So when I ask you for the x-intercept or the y-intercept, I'm asking you for a point. So I'd like you to give me both the x and the y coordinates, even if it's understood that one of them is 0. So in this case, x is 0, so the y-intercept is 0, 1/3. To find the x-intercept, we set y equals 0, so we get 4x plus 3 times 0 equals 1. So 4x equals 1, x equals 1/4. Okay. So the x-intercept is 1/4, comma 0. Okay. Yes, we will have fractions in this class. Just to go through some other examples real quickly. In fact, what you might want to do for the next 3 examples, you might want to pause the video and work this out on your own. So I'll let you do that. Okay, now assuming you've already done that, let's look at example 7. To find the y-intercept first, we plug in x equals 0, so y is 0 squared minus 4, so y is 4, so we get 0, 4. To find the x-intercept, we set y equals 0. Okay, so 0 is x squared minus 4. You can take the 4 to the other side, or add 4 to both sides. So we got 4 equals x squared. And in this we'll have 2 solutions, right? X is going to be 2 and -2. Okay, so we get 2 points, 2, 0, and -2, 0. Okay. For example 8, we set, to find the y-intercept, we set x equals 0. Okay, so similarly we can add, maybe we could add y squared to both sides, and then take the square root, get 3 and -3, so you get 0, 3, 0, -3. For find the x-intercept, you set y equals 0. Okay, so x is going to be 9. So you get 9, 0. Okay, and then finally in this last example, y equals 7/3. That's an example of a horizontal line. Okay, so that's going to, and since 7/3 is not 0, this is not going to have any x-intercept at all, because if you set y equals 0, or say, yeah, if you set, well, let's first set x equals 0. X equals 0, there's nothing to do, right? So, so in this case, you have, well, well, you can see, once again, it's probably easiest just to graph this and see what's going on. Okay, so here's 7/3. The vertical line, there are no x-intercepts, and there's one y-intercept. So the y-intercept is just at 0, 7/3, and that's about it, right? Because if you say y equals 0, you get 0 equals 7/3. That's false, right? So there's only one y-intercept here. Okay. Then the last thing we want to talk about is some symmetry. Okay, and we'll be talking more about this in later sections, but just to show that some graphs have a certain symmetry. There are three types of symmetry that we're going to be interested in. A graph could be symmetric to the x-axis or the y-axis or the origin. And I think we can, it's probably easiest to see, well, if it's symmetric to something, that means an axis that's acting like a mirror. So, like in this first example, this graph is symmetric to the y-axis. This graph is symmetric to the x-axis. And algebraically, what this means is if it's symmetric to the x-axis, then if xy is a point on the graph, then x minus y is also going to be a point on the graph.